Today we discuss definition of boundary of a set. We know about set. That means set plays important role in mathematics. And today we're going to boundaries of a set. This topics and is related to matrix space. That means in matrix space how boundary of a set have that means found. Now we first start about definition of a boundary of a set. Let X be a matrix space and A subset of X. Then a point X belongs to X is said to be boundary point of A if every open set that contains X intersect both A and A complement with respect to X. That means X difference A both non-trivially. That means this open set intersect with a non-trivially and intersect with a complement with respect to x is non-trivially. Okay, so we write it. Then the boundary of a in x is the set of boundary points. Then the boundary of a in x is the set of boundary points of A in X. The set of boundary points of A in X. Okay, and obviously we denote it. We denote it. We denote it del A. Okay, then del A. That means how we represent this any open set. Okay, any open set U intersection A not equal to phi and U intersection X difference A not equal to phi. Okay, when X belongs to U, then this X is called boundary point. Okay, so the del A equal to what? Del A equal to those x belongs to U subset of X okay, such that U intersection A not equal to phi and U intersection X difference A not equal to phi. We write it in this way. We write it in verse. We also denote it one set. That means this one is some boundary of A. Okay. This contains those elements which element contained in a open set U, and this open set intersection A not equal to phi and open set intersection A complement with respect to X is not equal to phi. Now we're going to further discussion of some example of boundary points. Okay, we erase that portion and obviously we're going to some set and boundary of some set. Okay, we handle some example. We start from some familiar example. Okay, we first consider this one. A1 equal to here open A closed B. Then boundary of this point equal to what? Then boundary of A1 B what? Just singleton A and singleton B. Those are the boundary point. Okay, I've understood. I think understood. Then those are the boundary points. Okay, not a problem at all. Here some problem occur. Who created this problem I don't know, but this one is happen. Okay, so we are not visible this video at this time now. That means someone also create obstacle around this. Okay, now we also start another example we seen here. Okay, another suitable example we also seen here. This example also we do it. Okay, we write this one second. A2 equal to what? A2 equal to R difference 0. Then the boundary point is what? Okay, R difference 0. Then boundary point of A2 equal to there's some problem occur. Then we talk about then boundary of A2 be what? Just 0 point. Okay. Next we write 3. This one is what? A3 subset of R square. A3 subset of R square is given by A3 equal to what? We write here A3 equal to those x square plus y square where less than 1 and y greater than 0, union of minus 1 less than equal to x less than equal to 1 and y equal to 0, union of x square plus y square equal to 1 and y less than 0. Okay, then what happened? Then the boundary point of this sets B. Okay, if we consider this one is A3, then okay, then the set of boundary points of A3. Okay, then set of boundary points of A3 be what? In this way we write it xy such that x square plus y square equal to 1. Okay, union of those xy such that minus 1 less than equal to x less than equal to 1 and y equal to 0. Okay, then this one is the set of boundary points of A3. Now we're going to further discussion of A4. Okay, we write here for A4 equal to this set xy such that x square plus y square equal to 1. Then the set of boundary points of A for each A for itself. Okay, each A for itself. Then we also discuss some familiar example. Okay, now it is that portion. And how this one happened, obviously if we check about that, then this one is, that means also so this one is happen. Okay, here we talk about x equal to r and a equal to 0 open 1 closed, then del a equal to 0 1. How this one happen? Okay, since 0 belong 0, if we talk about v0 epsilon, then intersection a not equal to phi and v0 epsilon intersection r difference a not equal to phi. So this one is happen. Okay, since minus epsilon intersection a not equal to phi, and here minus epsilon intersection r difference a not equal to phi. Then again v1 epsilon for epsilon greater than 0 intersection a not equal to phi, and v1 epsilon intersection r difference a is not equal to phi. This implies 1 minus epsilon 1 plus epsilon intersection a not equal to phi, and 1 minus epsilon 1 plus epsilon intersection r difference a not equal to phi. Okay, so this 1 and 0 are the 1 and 0 with the 1 and 0 with the boundary point of 0 1. Okay. Then del a equal to 0 1. If we talk about another point, okay, that means x belongs to a any point other than, that means x not equal to 0 not equal to 1, but 0 is not here, not equal to 1. Then what happened? Then we also choose 1 epsilon equal to minimum of 1, that means this one epsilon equal to minimum of what? Minimum of 1 difference x and x. Okay, then we find bx epsilon intersection a not equal to phi, but bx epsilon intersection r difference is equal to phi. Well, so we also talk about that any point belongs to this is not in this point is not in this boundary point. Okay, so in this way we also discuss this one. Again we going to another example. Also erase this and going to further discussion of another example. Okay, Now we also write here one example: a equal to r0 subset of r square. What is the boundary point of a in r square? Okay, if we draw this figure, if this one be x, y, here 0, total fully r square, and r cross 0, that means second position is obviously 0. The second coordinate is 0, that means y coordinate is 0, that means lying on this line. Okay, second coordinate, that means if any point, that means x0 is lying where, sorry, y coordinate is 0 means lying on this one. Okay, I also do wrong. Y is 0. Okay, y equal to 0, that means lying on this x-axis. Okay, then this boundary point of this set equal to what? That means any point, if we considered any point of this set, then this one is boundary point. Okay, because if we considered x belongs to a equal to r0, then obviously b x epsilon, okay, subset of equal to what, equal to x difference epsilon x plus epsilon cross difference epsilon, okay, subset of what, r square. Okay, and this b x epsilon intersection this a not equal to 5, and obviously bx epsilon intersection r square difference a is not equal to 5. So del a equal to a, that means boundary of a set equal to a. Okay, then we erase that portion. Now we're also going to another problem. The boundary of an open and closed ball in Rn is the sphere. The boundary of an open or closed ball in Rn is the sphere. The boundary of an open or closed wall in Rn is the sphere del v xr, okay, equal to del v xr equal to his xr equal to y belongs to Rn such that dxy equal to r. Now we also discuss this portion now. Okay, how this one is happen? That means boundary of an open ball and closed ball. Okay, open ball in this way obviously discuss, we know about that y belongs to Rn such that dxy less than r, and closed ball Rn such that dxy less than equal to r. This one open ball, this one closed ball. Then what happened? Then obviously that means boundary of this point, okay, equal to what? Boundary of this point equal to del v xr. That means this one is v xr, this one is v closed xr. Okay, then del v xr equal to what? Simply r belongs to Rn such that dxy equal to r. Okay, those point, that means x difference. Okay, why this one? Because x difference y less than r. This implies that y difference, that means in this way we write here x minus r less than xy less than r. This implies that y difference r less than x less than y plus r. Okay, same thing is if, that means which points are, that means which points are boundary point, then which those points y satisfies which are boundary point. Okay, then we also think about that this point. Okay, which are no, that means just difference each are, then this point are boundary point. Okay, now we also going to further discussion of another example. Let B be an open ball in Rn. Then boundary of B minus a finite number of points. Then boundary of B minus a finite numbers of points. Okay, then boundary of this equal to how much? Let B be an open ball in Rn, then boundary of B minus a finite number of points equal to how much? We first talk about this one, a1 a2 dot 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 an. This one is finite, that means now B be an open ball, then B difference this one. If boundary, if, that means if this one, then this one is the boundary. Okay, then how much? That means boundary of a finite numbers of points equal to. Okay, first we talk about one open ball. Okay, so closed, that means B, if BXR then del VXR B, that means close to one is the boundary of this. Okay, that means here if this one, okay, del v, obviously boundary of this, okay, and union of this one, a1 a2 dot 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 a, this one are also is boundary. Then del b equal to what? If b equal to, if we consider bxr, then that means here that means then here del b equal to del bxr. Okay, if we talk about simply del of 0 1 closed, okay, difference a1 a2 dot 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 an, then what happened? Then this one equal to del v, boundary of 0 1 equal to how much? 0 1, okay, and here a1 a2 dot dot dot, okay, or in this way you write this union this, okay. Then we also discuss this one, boundary points, okay. Then we find this one is which one, that means boundary of b minus this one equal to del v union this, okay. And in this way we see these examples. We also erase that portion and going to further discussion of that, okay. Obviously we known about two, that means important result about it. We write one result here, okay. Let a be a subset, let a be a subset, let a be a subset of a matrix space, of a matrix space. Then del a equal to a closure difference a interior, okay. How we prove it? Okay, first we talk about x belongs to del a, then what happened, okay. Then simply we know about it, okay. X belongs to del a means what? Bx are intersection a not equal to phi, and b ax are intersection a complement, okay, a complement is not equal to phi. Understood? Then this implies what? This implies if for r greater than 0, well, then this implies what? This implies this one. This implies what? This implies bxr intersection a not equal to phi, and here pxr, that means x bxr intersection a complement not equal to phi means x belongs to bxr but which does not subset of a, okay. Then this implies what? Here x belongs to bxr, that means x belongs to those one, x belongs to this means x belongs to a this one, and this means X does not belongs to A interior. Okay, this implies that X belongs to A closure uh, and X belongs to A interior complement. This implies that X belongs to A closure difference A interior. Okay, now we're going to back to back. Okay, if we consider this one, then this implies this implies this implies this implies this. Then we write this one, del A subset of this one, and this one subset of del A. So del A equal to A closure difference A. Okay. Now we erase that portion. Okay, we're also going to erase that portion and going to discussion of another example. Here we let A equal to Z belongs to C, Z equal to R e to the power RT, R belongs to 0 1 and T belongs to open 0 to pi. Okay, then boundary of A equal to what? Okay, so simply boundary of A equal to Z belongs to C such that mod Z equal to 1. Okay, because this one is this one obviously one circle. Okay, this one from a circle, so this one is a, that means here if T equal to 0 then just star. Okay, if T equal to 0 then this one is just r, and T equal to 2 pi then this one is minus r. Okay, so union of this is P such that minus 1 less than equal to P less than equal to 1. Understood or not? I think understood. Okay, why? Because if we put T equal to 0 then Z equal to just R. Okay, and R belongs to 0 1, and if T equal to 2 pi then Z equal to what? Minus R. Then here R belongs to 0 to 1, that means this range is this, and this one obviously R equal to another one, then this one. Okay, now we're going to further one discussion of another topic. We erase that portion and going to further discussion of that. Okay, we also talk about this one, this problem. Let X A be a subset of a metric space. Let A be a subset of a metric space. Then what happened? Then del A equal to del of X difference. Okay, we also have to prove this. How we prove it? So easily. We know about that X belongs to del A implies what? BXR intersection A not equal to phi and BXR intersection x difference a not equal to 5 for r greater than 0. This implies that what? bxr intersection x difference a. Okay, sorry, if we write here in this way, x difference a not equal to 5, and here bxr intersection x difference a not equal to 5. This implies that bxr intersection x difference a not equal to 5 and bxr intersection x difference a not equal to 5. So this implies what? This implies x belongs to del of x difference a. So obviously this one is happen. So we write it this subset of this and this subset of this. So what happens? So we get del a equal to del of x difference a. Okay, then we also done all problems related to boundary of a set. Okay, so today we stop here.